Good morning, everyone. So thank you very much for having us today at DSA. It's our first time here. I've always wanted to be part of this, but never got the opportunity to do that. So I'm Allela. I'm a technical evangelist at Intel for AI and IoT and covering the region. So today I'll touch a bit about what we do, our offering in AI, and share some of the thoughts around what the opportunities are in this space. So a brief intro about myself. So this is how I look on a good day, but it's a bit melancholic today, so yeah, you can tell. So on the side, I run a social impact startup called Sign.io. So Sign.io is a sign language to speech translation glove meant to assist people with a speech impairment to communicate with the general public. So you wear the gloves, and as you sign, the gestures are translated to speech. So it emerged the winner of the American Society of Mechanical Engineers, which is a global competition for social impact startups, and was also a winner at the Royal Academy of Engineering for engineering innovations. So it's one of the things that I do on the side, and some of the applications, actual application of machine learning and the knowledge that we've acquired over time. On to what I'll discuss today. I'll go over our AI portfolio, what we have in this space, some of the programs we have, and resources for students, developers, and even professors and academia. So this is the Intel AI portfolio. We have an end-to-end stack of AI products. At the bottom, we have the compute or the silicon, the state-of-the-art Xeon clusters for numerical computing. Then we have the Intel Nevada neural network processors for deep learning training. We also have the Altera FPGAs, which are meant to, you can configure a custom, which are accelerators for various deep learning workloads. And other than that, we also have the Intel Movidius compute stick that's meant to accelerate inferencing at the edge. In addition, we also have, at the compute level, we have the IQ chips from Mobileye that's meant for autonomous driving. So that's the entire stack of the silicon at the bottom. And then to unleash the full power of hardware, you have to leverage software. So at the top of that, we have the libraries. And these are, the libraries have some primitive optimized functions to accelerate the numerical operations and some of the inherent deep learning operations as well. So some of them are the Intel Math Kernel library and the open source Intel Math Kernel library for deep neural networks. So if you have time, you can check out the GitHub repo. A number of very neat optimizations on deep learning around there. There's also the Python distribution, the Intel optimized Python distribution. And these optimizations are basically around parallelized threading, vectorization, Scala tuning, and yeah, I think like pretty much those are the core areas that we try to do the optimizations on. Then on the right, we have the Intel nGraph library. So this is meant to enable the deployment of any deep learning framework on any of these target hardwares to achieve peak performance. So you generate an executable from the frameworks you have at the top, and it interfaces to the hardware at the bottom. At the frameworks level, we've worked with various companies and open source frameworks to optimize them and distribute different versions of optimized deep learning frameworks. So from TensorFlow, Caffe, MXNet, Neon, and so on. So that is under the frameworks. And tools, we also have SDKs and tools meant to accelerate the development process. So some of the tools are the Intel Deep Learning Studio, that is in beta, and the Intel OpenVINO. So the OpenVINO is the Intel Open Visual Inferencing Toolkit that's meant for deploying heterogeneous inferencing applications on any hardware architecture that you have. And finally, the Intel Movidius Software Development Kit for developing applications on top of the Movidius NCS. So that's pretty much the entire stack, and I'll delve a bit deeper into some of the key components. So the Intel Neural Network Processor, the NNP, this is currently in beta, but will be available to the public in Q2 2019. So it's basically meant to, it's custom hardware to accelerate training. And the optimizations lie around two novel areas. The first one is the spatial architecture, where you have the high bandwidth mem units. So the high bandwidth mem units are meant to, you can have a tensor split across various HBMs. That's the units, and it ensures that the in-memory data is always close to the compute. So you save a lot of data because there's a lot of data transfer when training. So that is one essential area of innovation. Then the other one is around the flex point numerical data structure. So this is a new data type based off of that works off the 16-bit integer multiplier accumulator logic. So it's meant to also accelerate some of the operations. So once it's available, it's currently in beta, but hopefully should be open to the public sometime next year. Then finally, I think we also, we aim to provide an end-to-end pipeline for deep learning applications. So you train a model in the cloud on the GPUs or wherever you train them on. And then once you have your model, how do you deploy at the edge? So there's a very pertinent need for intelligence at the edge that needs to be addressed, and this will put things into context. So for this, we have the Intel Movidius compute stick that is meant for inferencing at the edge. So how this works is you train a neural network in the cloud. Once you get the model, you pass it through the Movidius NCS SDK to profile, tune, and compile it into a binary graph. Then from there on, you deploy it into, you deploy at the edge. So you can plug it into a Raspberry Pi, an app-squared board, or any Intel platform or any IoT platform to interface to a camera and get that data and make decisions at the edge. So it's a USB form factor. This is the actual form factor, how it looks like. No additional heatsink, no fan, no cables, or no additional power supply. And some of the applications, you can use it in drones, surveillance cameras, VR headsets, and low power, intelligent, and autonomous products. So this is the pipeline in the workflow. You train a model, then you pass it through the NCSDK workflow for the profiling, tuning, and compilation, and then you deploy and you prototype. So we actually brought a couple of these for the workshop, and we'll give them to Dr. Ernest to share with the attendees. So hopefully you'll get a practical feel of how to develop applications and deploy on the NCS SDK. And it's compatible with all the frameworks, TensorFlow, Caffe, MXNet, and out-of-the-box functionality. You can also scale the inferencing performance with multiple devices. So depending on how big the problem is, you can dedicate a particular stick to inferencing a particular problem domain and build up on that to make a more informed decision. So let's say you're identifying guys in a crowd. The first one could be to identify a person, then pass that to identify the facial features, then the next one to identify the actual activity or the emotions and so on. So you can build a really like a well thought out and clear application using the device. Back to the libraries, as I said, software is critical in getting the performance out of hardware. So the Intel Math Kernel library for deep neural networks, it's optimized, it's open source and optimized on operations such as matrix multiplications and vector operations. We also have the data analytics acceleration library called the DAL. It's meant for optimizing analytics on various frameworks like Hadoop, Spark, and so on, and the Big DL standard. Then Intel distribution of Python that's optimized for, it's a different distribution of Python that's meant to optimize and improve the performance of Python applications on Intel architecture. On the right, we have the Intel ngraph, the library that's primarily tasked with converting any deep learning framework into an executable that will run on any hardware. So heterogeneous computing to be deployed on the CPU, the GPUs, the neural network processor, FPGAs, visual processing units, and so on. So this is how it currently looks like. You have your framework, passes through the ngraph compiler, and then you get the executables that can be deployed on any of these. So that's important depending on which part you are focusing on in the deep learning application. Where are you working on? Are you working on an FPGA application, on a neural network application, or the MOVIDIAs, and so on? Then finally, not finally, we have the Intel AI Academy, which is a one-stop shop for all the AI resources that we have. And you know, it enables you to learn, develop, teach, and share content around AI. So we have online tutorials, webinars, student kits, and support forums for that anyone can go in and utilize. Then you get access to Intel optimized frameworks for deep learning and machine learning. In addition to that, we have exclusive and free access to the Intel AI Dev Cloud that I'll touch on in the next slide. We also have content curriculum that professors can use and lecturers can use for AI. And you can share your work through the various platforms that we have around DevMesh and Intel Developer Zone. So that's the link, and you can check out the content in detail. So the Intel AI Dev Cloud is a cloud-hosted hardware and software platform available to the AI Academy users, and it's for free, currently based on Xeon scalable processors. Those are the specifications, and you get 4 weeks of free access initially, and then depending on the need, we can extend that period. So it's free, and we envision a process where you not only provide people with the content, but you provide them with the platform to actually develop practical applications of this. So that's the rationale behind the AI Dev Cloud, and we've been seeing a lot of use and applications out of it. So a critical component that we realize is you can't really train, deep learning. You can't build capacity on AI, like using the traditional approaches of having a workshop at a university, for a day and then, and leaving for another place. So what we have in place is the Intel AI Professor Program, where we work with professors to share with them curriculum and resources to adequately teach students. So we have some coursework that's been developed in collaboration with Coursera around Machine Learning 101 and Deep Learning 101 and AI with TensorFlow. So it's an end-to-end curriculum that can be used in a classroom, because that's one gap that needs to be addressed. We don't, the universities don't have sufficient resources around this. So we develop that and share that with the professors for free. And they also get access to the optimized frameworks as well when they are doing the exercises. So it's a very practical, hands-on curriculum that's meant to impart actual skills, and you tackle problems when taking the course. Then you also get access to Intel Compute. So that entails the training component and the inferencing component. So it's a well-bundled coursework that at the end of it, the learners and the students should be able to develop an end-to-end deep learning application. So we currently have partnerships with around 14 universities in Africa that are using this. And the feedback has been very valuable and great, that they are getting real value and deriving value from having a tailored curriculum focused on AI and having the corresponding resources to actually do the assignments and show the practical applications. So this is the professor curriculum in detail, what we have for the Machine Learning 101, the Deep Learning 101. So you'll see some similarity with the Coursera course that we provide, but it's meant to train on all the key concepts in both machine learning and deep learning. Then finally, we also have the Intel AI Student Ambassador Program that we've been running in the region for about 5-6 years now. And through this program, we identify very enthusiastic students who have an interest in AI, and we train them on AI, and then they become ambassadors and spread the knowledge and share it with other students. So we have ambassadors across various universities. We have one in Dedan Kimathi. I think Chris is over there. That's the guy to reach out to. And just to attest to how, this program has been, like how impactful the program has been. So I went through the program myself a couple of centuries ago when I was in university. Kathleen over there, who's the head of data science at Africa's Talking, was also a student ambassador. So I think it's a great step to start your career in as a data scientist or a machine learning engineer in that regard. Then, so a couple of thoughts. I think, I didn't just want to speak about what we have as Intel AI. I also wanted to get the opportunity to share some thoughts on what I think are some of the key opportunities, risks, and areas that we need to address in machine learning and AI ultimately. So I think the first one is the fundamental questions we need to have. The first one is around the data structures. As it is, if you look at the deep learning pipeline, you have the data sets and you have the data structures that map the data sets over a neural network, right? And we've pushed the frontiers, and we've been able to develop a lot of applications around this, but probably there exists an opportunity to optimize the basic fundamental level of data structures. Because think of it this way, I think some of the bottlenecks still exist in NLP could be perhaps because of the data structures that are not able to adequately capture and encompass the context and transfer the nuance from one point to another. Tensors have been able to do this quite well, but I think there's room for improvement. Could explore some alternative forms of tensor implementation. There are a number of those, or even just build on new mathematical constructs around this. So you might wonder, why is it really critical to look at the data structure again in terms of advancing the field of AI? I think this is important. If you look at tensors as they are, they've completely led to a new hardware implementation, right? So everyone is trying to create customized hardware for deep learning around the tensor technology. So you have the TPUs, you have the neural network processors, and all these other accelerators. So it will span the entire stack of optimizing deep learning applications. I think we've done a lot at the top stages. You just need to come back to some of the building blocks around the data structures and how that maps a particular data set onto a neural network. So what kind of architecture does it end up having? What shape of the network does it end up having? Those are some of the fundamental questions that we need to sort of, I think as researchers, and this is a right setting to put that across, need to address and look at. Then the other item, I think, is around the ecosystem. I think there's an imperative need to have a cross-functional multidisciplinary approach to AI. So having a decent, a good working relationship and collaboration between the researchers and the industry. I think we have PhDs, machine learning PhDs here, researchers, but we are the people with the problems, right? If you think of it that way, we are the people with the solutions, but you actually need to work with the people with the problems in the industry to show the real impact of the technology. Because ultimately, a farmer or someone like a farmer or a retailer doesn't really care much for AI or the technology that's there. He only cares about the impact it will have and how it will improve his life. So we need to get more involved with the industry and work closely in this regard to work with the domain experts to to develop applications around this. So it could be in an exploratory fashion just to explore what the opportunities are. And that would be a good start, I believe, to have the conversation to ask them, what are some of the applications that you think we can develop around this? I've been to numerous events and developer workshops that we do where, let's say someone in the finance industry walks in, and then after the workshop he comes up and says, so where do I begin? How can I work with the industry? We can't work in isolation, and as you two say, sometimes you can't make it on your own, right? So we need to get that working and involve the industry a bit more, work with domain experts to create applications around this, because there'll be, and especially for Africa, we'll end up experiencing a really huge gap between the actual technology and the application if we don't embark on this trajectory quite early enough. When we've built the capacity, now we need to work with the domain experts to develop applications around this. So those are the major 2 points that I wanted to put across around probably, is there an opportunity to optimize the current state of the art, the neural networks from a point of view where we work with the actual data structures. And the other one is how do you build an ecosystem to show real value of the knowledge we have and improve the lives of others, especially in the continent. So I think that's pretty much it. Yeah, I think I've been on time. So any questions or any feedback? That's pretty much it. Okay, sure.
How does Nirvana compare to a GPU or a TPU?
So that's a good question. We don't have their, I don't have the comparative analysis here, but currently it's at par in the initial test. It's at par with the GPU, with the Volta 100 GPU from NVIDIA. So it's pretty much at par. Yeah. So it will launch under the name Crest Hill. Lake Crest, and it will be quite revolutionary, I think. Yeah. So perhaps once it's out for the public testing, you can check it out, and it will have access to the ResNet and all these topologies that you can run the test on to get a good comparison on the performance. Yeah. Any other question? So thank you very much. That means I was either very clear or otherwise, so I'll take the latter. But anyway, thank you very much for your time and hoping to, oh, sure.
Thank you for the presentation.
Yeah.
What opportunities do you have
Yeah.
to help the industry
Yeah.
implement some of that? Because one of the biggest problems is getting good talent.
Sure.
Out there is a problem.
Yeah.
There's some opportunities
Yeah.
that actually we are looking for to implement some of it.
Yeah.
Capacity problems.
Yeah.
So are you open to help the industry actually implement some of it?
So I think how we are addressing this is, we have to go back to the educational system, and that's why we decided to work with the professors at the universities to build that capacity from there. I don't think you can build adequate and comprehensive skills by having a one-day workshop at a develop hub somewhere and call those experts. So that's what we are currently doing. And this brings me back to a very good example. I don't know if you know of Covermead. So Covermead was one of the founders at Fairchild Semiconductors, which later turned out to be Intel. So one of the challenges that they faced when they're developing and designing some of the early chips was that there's a big gap between the technology and the industry gap. So the industry had its own problems, but the technology was had set off in a different path and wasn't working well with the industry. So what he did and how he was able to address this, he developed and orchestrated a full curriculum with Caltech around the industry problems. So it was actually the applications of these particular the application of the technology to some of the industry problems, and that's how they're able to build up the capacity. And a good number of the new employees in the semiconductor like all the major guys in the semiconductor industry were students who went through this program. So it ended up having a great impact in the industry. So an academic approach is ideal.
But that takes too long.
Yeah.
It takes too long.
Yeah.
So you need a start, right?
Sure.
You've got some people
Yeah.
in the industry, they know something, they're missing out on other things.
Yeah.
So they need a very quick program that can make them up to date on some of these things.
I
You
don't,
don't necessarily need to start learning about machine
Yeah.
learning because they know some of those techniques
Yeah.
already.
Yeah.
So you probably want a model,
Yeah.
an algorithm that works very well for certain prediction problems. And somebody probably just to think probably some of these advanced algorithms will work for you.
Yeah.
Predict for you.
Yeah.
But you can't implement a neural network. For example. You cannot implement some sort of Bayesian analytic thing.
Yeah.
So you need some very focused capacity building for people who are already doing some of these things. Something like that.
I think, if I'm understanding your question, if you look at it, you can look at it both ways, right? I don't buy into the quick and dirty approach where you need to build capacity quickly and get these guys to develop. It takes time to do concrete work. Yeah, I don't think there's a shortcut to. There's a quick path to building the capacity and getting them ready to address the problems. They won't have that understanding. It takes time to conceptualize and internalize all these. So I'd still, prefer a well thought out approach where you build up on the concepts and train people on the entire pipeline. So, but that's my school of thought. I don't know what other people think on the same. Yeah. 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 Yeah.
Upon deployment of maybe a project,
Yeah.
does it have the capacity of maybe facilitating the vertical, horizontal, or upstream?
So yeah, just say the last bit again. The last bit. What did you say? The last bit.
Does it allow
Yeah.
for vertical or horizontal scaling, or maybe it has some complex scaling?
Scaling in what terms? I think that is a bit.
For instance, if
Yeah.
if you have a data growing and
Yeah.
infrastructure is growing,
Yeah.
do you have to maybe add some sort of maybe CPUs?
Yeah.
particularly,
Yeah.
or-
So as it is at the moment, you have the Xeon clusters, and then to complement that, we have the FPGAs. So the FPGAs is sort of compute on demand. As the needs grow, you can reconfigure and assign more resources to it. So that's what Microsoft are using for the Bing search, and it's actually quite cost effective and scales well. So yeah, it addresses the scaling needs that lie in that in that domain.
Could you elaborate a bit more on the improvements to data structures, maybe with an example? Are you referring to like in-memory data structures, or elaborate that a bit more with an example?
So actually that's something I've been thinking about, and it's how I look at it. Like initially, you can implement a neural network over any data structure, right? It's just you can think of it as a graph, and there was an optimization. You had the optimization for matrices and vectors to the tensors. So you began with the matrices and the vectors, then moved to tensors, which showed greater performance and greater results. So ultimately, I think we can still, we shouldn't settle where we are, because that seems like what's currently happened. We've now decided we are there and focusing on other areas. So probably, and the thing with AI is, it's a multidisciplinary approach, right? You need, like computer science builds on concepts from linguistics, psychology, chemistry, biology, physics, maths, and so on. That's why we don't have a Nobel Prize for computer science, yeah, because it's not an actual science, but it's built up on this concept. So it will take, like, probably a particular innovation or new thought processes from these other disciplinary areas, probably even the linguistics, to be able to build upon these and improve the existing architecture that you have. So it's more of trying to optimize what you have at the moment, because we've seen that you're able to do that, right? So how do we move from there? And there are papers on the alternative forms of tensors, which are very interesting. And if you look at the actual complexity in terms of the cost of the tensors, it's still a bit quite costly. That's why training is such a Herculean task. But if you can rework that to be able to have efficient training with factors around scaling across multiple nodes and efficient utilization of the compute resources, then I think you're onto something. Yeah. So that's something. Yeah. But we should have that conversation much later in person, and I'll give you a few pointers on which areas are. So, any other question? So thank you very much for your time, and enjoy the rest of your workshop.
Thank you.